So next, we're going to start building on what we already know, and we're going to add arrays into our JavaScript, and we're going to talk about how we control the flow of a JavaScript program. So we should be able to create an array, access the collection of HTML elements by type, view arrays, create programs using loops, the while, do while, and for. We're going to look at array methods that can possibly replace program loops, and we're going to look at our if statements and switch statements. We are able to store data in a data structure called an array, which is a set that is represented by a single variable name. And in order to do that, typically they're related in some way, shape, or form. And the way that we do that is we use the word let again, just as if we do with our regular variables. We give it a name here where it says array, and that equals, and we put values in the square brackets. Here we can see an example of weekdays, and we put a bunch of different strings. So Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. You can see again that in JavaScript, we do not have to say what kind of data is in there. And we are going to separate them with a comma, or we don't have to put anything in it and it'll be empty. Now, we can also create it with an object constructor where we say let our variable name array, whatever name we give it, equal new array with a capital A, and then in parentheses, either give it a values or give it a length. And the length would be how many elements we're storing in there. Later on, we're going to talk about control of flow, and that's just the order in which the code is executed and in ways that we can actually control when and where we do certain items. Just as in C, what we've learned, an element is a value stored in an array, and the index is the position. We start our indices with 0, just like we do in other programming languages, and then we can increment by 1. If we want to look at what's in a specific, to set a specific index value, we use the array name, and we use the square brackets with the index in it, and then we say can equal a value. The biggest difference between JavaScript and other languages is that JavaScript arrays are dynamic. So they are automatically going to contract and expand to allow for new elements. That allows us to create sparse arrays, so smaller arrays, in which some values are left undefined, so the length is greater than the number of defined values. We can also determine the array's current size with a method called .length. So here you would have the array name, and you can say .length, and that will give you the number of elements that are currently in that array. Here are some examples on storing data in arrays. So this first one, game dates equals, and it's a bunch of strings. They're all separated by commas, and we're doing it within the square brackets. The same is for the game opponents. For locations, we have characters here. Again, they're all separated. Runs, that's going to be a numeric. Runs allowed, numeric. Game winnings, numeric. And then results, win, lose, suspend, or postpone. And all of this information corresponds to a basic calendar for the Tipton Turbines baseball team. We can have multi-dimensional arrays, which are going to look like this matrix, or what going to look like a matrix, or like a table with rows and columns. JavaScript does not support an actual matrix, but it will support a multi-dimensional array. So we can use that to mimic the behavior of a matrix. It's very similar to what we do in C. We've got the open and close square brackets on the outside, and then each row listed within the square brackets, all separated by commas. So expression array xy, x is the outer array or the row, and then y is the inner array or the column. And if we use that length method on this, it is going to return the number of rows applied to the first row to return a number of columns. So if we say marray.length, it's automatically going to give us the number of rows. If I say marray square bracket 0 square bracket dot length, it's going to then give me the number of columns. We have a bunch of different collections in HTML that we can use in our JavaScript to benefit. So here we've got embeds. It will embed an element. We've got forms, which are form elements in a document. We've got form.elements, elements within the form. Get elements by class name, get elements by name, get elements by tag name. These are the same as what we used before, which was the get element by ID. You could just get them by different types. We do have an image element. We have where we can add links, and a link is the one that's usually the oddball, and it's an A for an area. We can also have scripts like we've been doing, and we can add style sheets. If you've been using the GitHub desktop, we have been downloading some .css files, and those are those style sheets. That's going to give you the colors of the background and shapes and sizes. You don't always need them, but they are good to have to pull that out of your HTML and have it separated. We can reference an element within a collection. So we can either say objects and then an ID reference, or object.id reference. So the object is the HTML collection, and the ID reference is the index number for the position or the value of the ID attribute assigned to that element. We can search through that document object model and get the syntax. So if we want to search through that DOM, get elements by class name, class tag name, and by name. Again, this is very similar to the get elements by ID that we've been using in the past. It's just 3 other ways to actually access a specific item. We can add the index in brackets to reference a particular element, and we can also nest them. So here you can see get element by tag name, and within that array, we're getting an element by a tag name as well. Viewing arrays and HTML collections within the console. So this is in that developer tools, more tools on the right. Here, if you go to console, it will give you a display of some of your different arrays with some information in it. So here, game dates.length, it has 23 dates in the array. Game opponents 4, index 4, the opponent on the 5th game, remember index 4 is 5 because you start at 0, is Clinton, and over here the results is they lost. Documents.links.length, it's going to be the number of hypertext links in the document. There's 5. And here we've got that inner HTML. So document.link sub1, inner HTML, the second link is going to be the calendar. And then here, game opponents of 23, because there's not a 24th value, instead of doing an error message like we would have had in C with an index, array index out of bounds, it just goes to an undefined because it is dynamic. It grows and shrinks with what we need. A program loop is something that is going to be repeated until you decide it needs to be stopped. The while loop is going to execute as long as a condition is met. So here we have our syntax while a condition do certain statements. We call an iteration 1 repetition. So if I do it 4 times, it has gone through 4 iterations. And we include at least one statement that eventually results in a value in which that would stop. That otherwise we're going to have an infinite loop, which just means it's going to go on forever and ever and ever. In order to get rid of an infinite loop, we need to force close or force quit the browser. Is just as if we were in C, we had to close that console window. Well, now we just have to close the browser. But the syntax looks very familiar to what we had before. And make sure that you change whatever that condition is within these statements, or you will go on forever. So the while loop here is a counter. A counter is typically a variable that changes with each iteration. or it's just something that you use to keep track of where you are. So here's a sample. I've got let I equals 1. I'm using my I here as my counter. So while my I is less than or equal to 5, it's going to write out the number with a BR tag for the HTML, which is a break. Then it's going to increment it by 1. So it's going to start at 1, and it's going to print 1 break, 2 break, 3 break, 4 break, 5 break, and then it's going to come down here and say the value is equal to I, the value of I is equal to 6, and then it's going to end that paragraph. While we work with program loops in JavaScript, we have a few different ways to iterate our counter variable. So here, for example, I have an I with a plus plus after it, and that will increment it by 1. So if I start at 5, I go 5, 6, 7, 8, 9, 10. The same thing happens with a minus minus. If I go as long as it's greater than 0, it'll go 5, 4, 3, 2, 1. I can do the plus equals, which is the shorthand way of saying I equals I plus something. And so it's going to go 60, 120, 180. I can do the same thing with the multiply and the divide. So this would be I equals I times 2. So 2, 4, 8, 16, 32. And this would be a divided by. So 90 divided by 3 is 30. 30 divided by 3 is 10. So you can use any of those iterations in your while loop. Here's an example of working with some of those loops. So here on our first line, we've got that array definition. Here we're adding an event listener to the window. So on load, it's going to call the add weekdays function. So my function add weekdays here, I've got my initial counter variable. I started it at 0. Here I am creating a variable called heading cells, and it's going to store the collection of all of the TH elements in the document. But the part that I want you to really zone in on here is the loop down here. So while I is less than 7, heading cells of I equals dot inner HTML equals weekdays sub I, and then we increase the I. So for each of the TH cells here on the inner HTML, I'm going to set it equal to a weekday. So here I've got it going through Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And those names are generated from this weekdays array here. So I'm setting the heading cell equal to the appropriate weekday. Then, of course, I increase it by 1 by doing the I++. Just as in C, we've got a do while along with our while loop. So the while is a pretest where you check the condition before you do any statements. A do while is a post test. So that means that you're going to do the statements at least one time and then check the condition after and towards the end. So my syntax is do curly brackets, and you put all of the things you want to do within there, and then while condition. So other than when you execute and when you stop, the while and the do while loops are going to be the same. The next type of loop that we have is a for loop, and just as in C, it is a pretest loop that is going to give an initial condition, a stopping condition, and your iteration. And our syntax for that is for initial condition, the stopping condition, and then the iteration with the curly brackets and the statements in it. So for example, I can actually put my let though for my variable in the for. So let I equals 1. As long as I is less than or equal to 5, increment I by 1, and then my statements, I say document.write, and then I put things. Your for loop is your preferred method for writing loops. It is a little bit safer when it comes to not being able to create an infinite loop as easy. So we can put loops inside of loops just like we could do with C, so we can nest them. So for example, here I've got an array and it is a table, so you've got your rows and columns. So your outer loop here, which is the first for with the first set of curly brackets, that's going to iterate through the set of the table rows. Then within each row, I want to write all of the columns. So that's what the center loop or the inner loop here does. So it creates a table. It's got rows from 1 and 2. So there's 2 rows. Then it's going to print each of the values going in each column in the center one, and then you're going to end your row and end your table. Here we have some syntax for creating a for loop that iterates through contents of the array. So let I equal 0, I less than objects.length. This is a nice, easy way to go through an array without having to figure out how many elements are in it. We can use that length. So this right here is a sample loop to apply an event handler to every input element. So all inputs equal any element that is considered an input element. For let I equal 0, all inputs.length. So it's going to give you all of the inputs that are in here, and it's going to go from 0 to that. On all of my inputs, I want to add the click, and then when I click, I'm going to check order. Here, finally, is a method for inserting an additional content into an element, not overwriting it. So element insert adjacent HTML. That's going to give you the ability to concatenate or append and not overwrite. So here I'm going to give it a position and the text. So I can either do before begin, after begin, before end, or after end. And that's going to be the 4 locations that I can insert this text. Now, if I am to add some additional information into the code we've been looking at before to add game information onto our calendar. So here I've got adding an event listener to window on load. It's going to show games. So my show games function is a function here. And for I equals 0, game dates. So it's going to go through all of the game dates and set the game information to blank or nothing. It's just going to be 0. It's going to be nothing there. Then we're going to open a paragraph, which is going to be the start of where we're putting these items. Here, game info plus equals. So remember, that means game info equals game info plus. So to the game info, it's going to add the opponent in that index and a break. This is all within that first for loop. Then it is going to put the game result with a colon and a parenthesis, and then the runs dash runs allowed. Here it's going to close that paragraph, and then it is going to write the content into the table matching the date. So let the table cell equal game dates. It gets the dates of the date that's indicated. And it's going to insert adjacent. Before the end of it, it's going to add in game info. What that's going to do is it's going to march through this table. So here, for example, on 1, it's going to create the text that says Marion break win colon 4-2. So that's where you're getting the opponent break, result, which is the win or loss, and then the scored and the allowed, which is the scored and then the allowed. And then it's going to add that to the table. So that one loop right there is going to add all of that info. Now, we've got a few different methods to generate loops. JavaScript has built-in array methods that can replace some loops. Sometimes they're faster and making your code simpler, more compact. Each one of these is going to employ something that we call a callback function. And that is a function passed as a parameter to another function. So our functions are passing functions. So for example, I've got for each method, which is going to call a function for each array element. So in each element of my array, named array here, I'm going to do a callback with this argument. Now my callback function is going to say function callback array value, index array. So the biggest difference in to be able to use this are these parameters that are being sent in this function. And that's really the key of this. So to create an efficient loop, place all the calculations that are not going to change during the loop outside of the loop. So again, you just want to put what's in the loop in the loop. Looking at an example, let's do a for each method that is going to change the array values of 1, 3, 5, 10 to 6, 8, 10, 15. We're adding 5 to each one of those elements. So here I've got X is my array, X dot for each. So it's going to do for each and every element, it's going to call the step up 5 function. Now in my step up 5 function, I've got my array value, my I, and my argument. That's how it has to be set up in order to work. And my array sub I equals array value plus 5. So your array value is the value of the array element at each iteration. I is your index, and array is the name of the array. There are a few other methods that we can use and for our arrays, for loops. We have one called every. That's going to test whether the value of the callback function is true for all of them, all of the array elements. So something good for that would be like when we did the input checking on the text boxes, something like that. Filler is going to create a new array populated with the elements of the array that return a value of true. For each is going to give every single element to do that same callback function. And then finally, we've got map. That's going to create a new array by passing the original elements to the function, which is going to return the mapped value of whatever that element is. We've got reduce, which reduces the array by keeping only trues. Reduce right reduces the array starting from the last and heading back to the first. Sum is if it is true for at least one element. Find is going to give you the value of the first element returning a true, and then find index returns the index of the first element returning a true. So you can see these will make coding a little bit easier and quicker to go through. Now, decision making is the process of choosing which code to execute in response to a specific circumstance. So decision making structures or statements or conditional statements, those are all meaning the same thing. We're going to use an if statement, and it is going to run a set of statements only if the given condition is true. So if condition, do these statements. A sample if statement, if day equals Friday, window alert, get ready for the weekend. The triple equals, remember, is that it means it is the actual element and object and data type and object type. We also have the if else. So if a condition is true, it's going to do one set of statements, otherwise do another set. So if condition, statements if it's true, else, statements if it's false. Sample if else, if the day is equal to Friday, get ready for the weekend. Otherwise, just have a great day. The else if. So this is multiple if statements put together. So maybe you have one of 3 different choices. So if the condition is true, it's going to do one thing. Otherwise, check for a different condition. If that condition is true, it'll run a different set of statements. You can put as many else ifs as you want in a structure, and then your final one is typically an else. Here we've got some decision making into our calendar. If the game's at home, display the text versus, otherwise display the at character. So that's going to give you a difference of whether it's a home or away game. So here, if the game location equals home, in the game info, add versus. Otherwise, if the game location is an A for away, add the and sign. So here we can see it's an away game because it's at Marion, and this would be a home game because it's versus Clinton. Again, here we've got some additional information that we're adding onto this baseball chart. So if the number of innings is less than 5, it's putting some asterisks after it. So here we have a suspended game, and so therefore we did not do all 5 innings, so it puts 3 asterisks at the end. If the game is less than 9, we put a star, so it is a shortened game. So here, like we can see here, it only went 6 innings. It was a shortened game because of the asterisk. And finally, if it is more than 9, it went extra innings. So print how many. So for example, here down at the bottom, it went 10. So it did add the 10 on there. So you get to see the if and the else if at work. Now, because if it went exactly 9 innings, we didn't want to do anything. We didn't have an else that's a catch-all, but that's really the only reason why. We can also nest our decision-making structures, so we can put ifs, inside of elses, things like that. And we just have to be careful that we don't get lost in our spaghetti. So if day equals Friday, if it's 8 a.m., start. If it's 5 p.m., time to start the weekend. Otherwise, a few more hours. If it's not Friday, it's going to come down here. Is it Monday? Start of another week. If it's not Monday or Friday, it's going to do this last one. So you can put as many of these in within each other that you need to. Program code should be supported by various browsers. We don't know whether they're going to be using Chrome or Edge or Safari or some other one. So what we can do is we do have browser tests that are going to confirm that a feature or a part of your script, whether it is supported or not, within the browser that you're working within. So you can use something such as an if statement to look for a specific feature, and if it is available, do something. If it's not available, do something else. So here, if I meet a specific feature, here's my statements that use the feature, otherwise statements that do something else. So for example, if I am on a mobile browser, I may want it to look and feel and say something. And if it's on a regular traditional browser on a desktop, it may say something else. We have a sample browser test for the find method. So here we've got some order IDs. If you find an order, okay, so it's going to find the first order. So the find method is supported by the browser. Let the orders find the unshipped, otherwise find something else, okay? Unshipped here, callback function determine whether an order has been shipped or not. So orders.find. Finally, we do have a switch statement just as we had in C, and we say switch and we put the expression test with the curly brackets, and then we have case and the value and the colon. And usually we do a statement, then we do the break so it gets out of that switch. We also then have the default statement, which is going to be the catch-all. Here I've got some switch statements, and it's going to add some color to my table. So if my game result is a W, I want to open a tag for games 1, and I'm going to say that I'm going to color it green. So that's what this is doing here. My second case is an L or a loss, or I can have an S for a suspend, or I can have a P for a postpone. And each one of these is doing a different color in the table. So here, for example, I've got a P for postponed. It's a gray. S for suspended is yellow. W is green. And L is red. And then once it finds its case that it matches, it does do a break after, which just takes it out of that switch. So your break and your continue are very similar to what we did in C. Your break is going to direct it to exit the loop and just keep going on the next statement. The continue statement is going to stop the current iteration and continues on to the next iteration. So that is actually useful if you want to skip an iteration of the loop. So for example, I've got a for here. If my email is undefined, just go to the next loop. If there is an email there, send an email to that address. We can use statement labels to identify statements in the code so that we can reference them wherever we are within the program. This is useful a lot of times when we need to exit a loop or nested loop early, and we want to direct the flow in order to get to a specific set of statements rather than the next statement. You're explicitly telling it to go somewhere and do something specific. So my syntax is label double dot statements colon. The reference syntax could be break, label, continue, label. Okay. Usually we don't do this unless it's absolutely necessary, because it does kind of go back to those basics and where we used to use things like a go-to, and you can create more of a spaghetti code, but it is something that's available. Hopefully you have been able to create an array listing with a bunch of different values, access some HTML types, and their collections, view arrays and the collections using the browser console, create program loops using the while, the do while, and for, and also exploring array methods to replace loops. Finally, we talked about making decisions with if statements and switch statements, and we did talk about break and continue, and finally the label command.